Light-duty logistics trucks. This is where it all starts in logistics, the lightest trucks on the road, with a gross vehicle weight rating under 14,000 pounds. This category covers everything from global pickup platforms like the Ford F-150 and Toyota Hilux to commercial cargo vans like the Ford Transit and Mercedes-Benz Sprinter. These are not the massive heavy-duty rigs hauling freight across continents. They are the everyday workhorses idling in urban neighborhoods, delivering parcels or transporting tools to local job sites. These trucks show smart practical engineering in action. Manufacturers start with everyday vehicle platforms and turn them into tough, affordable work tools. Vehicles like the F-150 or Hilux rely on a rugged body-on-frame chassis. When configured for light commercial logistics, this frame handles constant, heavy daily use without structural failure. With cargo vans like the Transit or Sprinter, the focus shifts to internal volume. Designers optimize every inch of the wheelbase and roof height to maximize usable space. A high roof configuration can offer up to 487 cubic feet of cargo capacity. This volume is achieved through near-vertical sidewalls and flat floor lengths, allowing operators to stand upright while sorting cargo. It is a design focused entirely on utility within a standard vehicle footprint. While horsepower often gets the most attention in automotive discussions, urban logistics depends heavily on low-end torque. Constant stopping and starting on city streets requires immediate force to move thousands of pounds of cargo from a dead stop. This requirement favors twin-turbocharged gasoline engines and small four-cylinder turbo diesels. These power plants deliver peak torque, often exceeding 400 pound-feet, at low engine speeds around 2,500 revolutions per minute. Combining this low-end power with a tight turning radius allows these vehicles to navigate heavy traffic, climb steep residential hills, and access narrow alleys efficiently. Medium-duty logistics trucks. Once you go past the 14,000-pound mark, you leave the world of regular vehicles behind completely. This is the medium-duty realm, spanning Class 4 through Class 6 with a gross vehicle weight rating scaling from 14,001 pounds up to exactly 26,000 pounds. It represents a critical operational bridge in global supply chains. Operating these machines requires an entirely different level of spatial awareness, shifting driver metrics from personal transport comfort to pure industrial utility and daily commercial endurance. Look at how the harsh geometry dictating urban logistics forces a sharp design split within this single category. On one side, you have the cab-over-engine setup utilized by the Isuzu NPR, which places the driver directly over the front axle. On the other side sits the conventional extended hood configuration of the Ford F450, F550, or Chevrolet Silverado 4500 HD. For regional beverage delivery trucks operating daily in tight, crowded city grids, horsepower takes a back seat to sheer vehicular geometry. The Isuzu NPR delivers a turning radius as tight as 16.5 feet, allowing a massive 20-foot box truck to slice through crowded intersections that would leave a conventional, long hood truck completely trapped in a frustrating multi-point turn. This dramatic difference proves that maneuvering efficiency outvalues raw speed when navigating tightly packed urban storefronts and cramped commercial loading docks. Once these vehicles escape city limits, a completely different engineering headache emerges for fleet operators. Box trucks are essentially giant bricks on wheels, presenting a massive flat surface area straight into the oncoming air. At highway speeds, aerodynamic drag increases exponentially, forcing the inline-6 and V8 turbodiesel power plants underneath to fight an invisible wall of air resistance constantly. These engines are calibrated to maintain steady cruising speeds under immense drag while carrying broad, heavy payloads. It requires heavy-duty cooling packages and specialized transmission programming to keep the powertrain from overheating while maintaining fuel efficiency on cross-country delivery routes. Heavy-duty logistics trucks. This is where the scale changes completely, moving into the realm of absolute mechanical scale. Class 7 and Class 8 trucks start at a gross vehicle weight rating of 26,001 pounds and easily top out at 80,000 pounds for a fully loaded 18-wheeler semi-trailer setup. These are the long-haul titans of the interstate highway system. Everything about them is oversized, built exclusively to move massive industrial freight across thousands of miles without stopping. The sheer presence of these commercial vehicles dictates highway traffic flow, demanding heavy-duty infrastructure and massive lanes just to accommodate their physical footprint and immense rolling kinetic energy. The power plants driving these machines are pure mechanical overkill designed for endless duty cycles under extreme thermal load. Forget small displacement blocks, aluminum heads, or lightweight internal components. These rigs rely on massive 12-liter to 15-liter inline-six diesel engines manufactured by industrial heavyweights like Cummins, Detroit, or Packard. Cast iron blocks and heavy steel connecting rods are mandatory to survive the intense combustion pressures generated within the cylinders. While sports cars love to brag about horsepower, these giants only care about raw pulling power. An ordinary Freightliner, Peterbilt, or Kenworth engine churns out up to 2,050 pound-feet of torque at just 1,100 revolutions per minute, meaning it generates maximum pulling power barely above an idle. This immense torque is what keeps an 80,000-pound load moving forward against gravity up steep gradients. Managing that much rolling mass requires absolute precision in power delivery across changing topography. Drivers utilize complex 13-speed or 18-speed manual transmissions, using dual countershafts and air-actuated splitters. This setup allows the operator to split gears, keeping the massive engine inside a razor-thin power band of just 300 revolutions per minute while climbing steep mountain passes. This prevents the vehicle from losing forward momentum, which would otherwise stall the entire rig and hazardously strand thousands of pounds of freight on narrow mountain highways. Progressive shifting techniques and perfect rev matching are mandatory, turning heavy truck operation into a highly disciplined mechanical skill rather than just simple driving. The application of this brute force extends far beyond highway cruising. Consider heavy-duty dump trucks hauling raw construction materials through punishing off-road environments. To dump a 20-ton payload of jagged rock, these trucks utilize telescopic hydraulic cylinders pressurized up to 3,000 pounds per square inch, focused onto a single pivot point to lift the massive steel bed smoothly. The pump driving this fluid pressure extracts mechanical energy directly from the main transmission via a heavy-duty power takeoff unit. It is a showcase of heavy industrial hydraulic engineering operating under extreme stress, converting diesel fuel into immense lifting force capable of shifting mountains. Trailer-based logistics trucks. To really understand long-haul efficiency, you have to stop seeing the semi-truck as just one vehicle. It is actually a modular pairing of two distinct components, the tractor and the trailer. The tractor provides the mechanical muscle and driver habitat, while the trailer dictates the cargo mission. By separating the power unit from the storage unit, logistics networks keep engines running constantly while trailers are loaded and unloaded independently. This modularity relies on a single mechanical interface known as the fifth wheel. This heavy, grease-coated steel horseshoe mounted on the tractor chassis receives the trailer kingpin, locking the two massive entities together. The fifth wheel plate manages a brutal physics equation, directly absorbing up to 40,000 pounds of vertical tongue weight, while simultaneously transferring over 60,000 pounds of horizontal pulling force through a single heat-treated steel pin. This coupler allows the entire rig to articulate smoothly through corners, preventing the massive combination from snapping under extreme shifting weight loads. Once connected via the fifth wheel, the tractor adapts to whatever trailer configuration the supply chain requires. The most common iteration seen dominating the highway system is the dry van trailer. These aluminum boxes, typically measuring exactly 53 feet in length, provide a completely sealed, weatherproof environment to transport non-perishable consumer goods, electronics, and palletized freight across vast distances safely. When the cargo cannot fit inside a standard box, logistics operators swap the dry van for a flatbed trailer. Lacking walls or a roof, the flatbed is a raw structural steel platform designed for oversized, heavy industrial loads like steel beams, lumber, or industrial machinery. Securing cargo here is a serious mechanical discipline, relying on heavy-duty steel chains, binders, and synthetic winches cranked down with hundreds of pound-feet of manual force to ensure heavy steel components do not shift during highway transit. For global trade, container chassis trailers connect maritime shipping with overland trucking. These specialized skeletons use mechanical twist-lock mechanisms located at the chassis corners. By dropping a standard 20-foot or 40-foot ocean container onto the chassis and manually twisting the heavy steel locks 90 degrees, the trailer secures an intermodal steel box into an unyielding part of the vehicle structure. Finally, moving extreme heavy machinery like industrial excavators or oversized transformers requires a step deck or lowboy trailer. These trailers feature a dropped center deck that rides just a few inches above the asphalt. By lowering the vehicle center of gravity, a lowboy allows oversized loads to clear standard highway overpasses safely, avoiding catastrophic collisions with concrete bridge structures. Specialized logistics trucks. Standard freight relies on uniform boxes. However, when cargo becomes volatile, temperature-sensitive, or physically dynamic, standard trailers fail completely. This forces the deployment of highly engineered machines tailored to handle specific chemical or physical challenges. These vehicles must manipulate thermodynamics and fluid dynamics while traveling at high speeds. Take reefer trucks, which are designed to resist external thermal environments. A reefer is essentially a heavy insulated structure paired with an independent nose-mounted diesel refrigeration unit. This secondary engine runs continuously, independent of the tractor. Even when ambient outdoor temperatures exceed 115 degrees Fahrenheit across desert highways, the refrigeration system forces sub-zero airflow throughout the cargo space, maintaining a constant temperature of -10 degrees Fahrenheit to protect pharmaceutical supplies or food products. When transporting bulk liquids like gasoline or hazardous chemicals, logistics networks deploy tanker trucks. These vehicles represent a constant struggle against fluid mechanics and momentum. When a half-empty tanker breaks or enters a turn, the liquid cargo rushes forward or sloshes sideways. This fluid shift creates a powerful momentum wave known as the surge effect, which can easily push a heavy vehicle into an uncontrolled skid or flip it entirely. To solve this, engineers weld internal metal bulkheads with precision-drilled holes, called baffles, inside the cylindrical tank. These structures allow the fluid to flow slowly while disrupting the destructive sloshing force entirely. Vehicle transport requires a completely different mechanical solution, delivered by car haulers. These skeletal rigs use intricate networks of hydraulic ramps and screwjack lifters to maximize vehicle capacity. Operators slide full-size SUVs and low-slung sedans onto overlapping split decks. The hydraulic system positions vehicles at precise angles, leaving clearances of just 2 inches between the roofs and bumpers of different vehicles, without allowing any physical contact that could scratch the paint during high-speed highway travel. Finally, moving wet concrete introduces a race against chemical hydration. Cement mixers use a rotating drum to keep the heavy mixture moving continuously, preventing it from solidifying into solid rock during transit. This continuous rotation requires immense mechanical force. Instead of adding a heavy secondary engine, the mixer uses a power takeoff system linked directly to the truck main engine crankshaft. This system redirects up to 100 horsepower from the truck drivetrain to turn a drum filled with 40,000 pounds of wet concrete, maintaining the aggregate in a fluid state until delivery. Last-mile delivery trucks. The long highway journey ends at the suburban boundary. Here, massive rigs hand over cargo to a highly specialized fleet designed for the chaotic final leg of the supply chain. This is the last-mile delivery sector. It is an urban battlefield forcing a rapid shift toward advanced electrification and extreme ergonomic efficiency. The streets are now dominated by purpose-built electric delivery vehicles like the Rivian EDV and the modular Canoe. Conventional internal combustion engines struggle in dense urban environments due to constant idling and heat buildup. Electric powertrains eliminate these inefficiencies completely. An electric delivery van produces 100% of its peak torque at exactly 0 revolutions per minute, launching a fully loaded vehicle effortlessly off the line thousands of times a day without burning a drop of fuel. Furthermore, the constant friction wear that destroys heavy-duty service brakes is mitigated by regenerative braking. This system reverses the electric motor to slow the vehicle, converting kinetic energy back into battery power while preserving mechanical brake pads for weeks. Physical vehicle layout plays an equally critical role in saving operational time. Traditional package delivery relies on step vans operated by companies like FedEx and UPS. These vehicles feature low step entry points, sliding pocket doors, and tall interior ceilings. A delivery driver might enter and exit the cargo area up to 200 times during a single shift. By designing a walk-through cabin floor that sits just 12 inches off the asphalt and providing a 77-inch interior standing height, these vans allow workers to grab packages and step onto the sidewalk instantly. It removes seconds from every stop, translating into hours saved across a national fleet. Warehouse and yard logistics trucks. Beyond the public roadways, behind locked security fences, sits the final category of supply chain transport. These machines operate exclusively within deep fulfillment centers and heavy container yards. They do not conform to highway regulations. Instead, they utilize unusual geometry to maximize material handling speed in confined spaces. The most vital machine in a major shipping hub is the yard truck or terminal tractor. These short wheelbase vehicles feature a single-seat cabin and a specialized hydraulic fifth wheel. In a standard highway tractor, a driver must manually crank the trailer landing gear up and down, a process that takes minutes per hookup. The yard truck eliminates this labor entirely via a heavy hydraulic lift that elevates the fifth wheel plate up to 12 inches while under full load, allowing the driver to reposition heavy 53-foot trailers without ever leaving the cab. This mechanical shortcut saves hours of labor during massive yard shuffling operations. Inside the warehouse walls, space becomes even tighter, forcing a reliance on forklifts and reach trucks. These industrial tools utilize a unique rear-wheel steering configuration. While a passenger car feels stable steering from the front, rear-wheel steering allows an industrial lift to pivot completely around its own front axle center point. This configuration creates a turning radius of 0 inches. It allows a machine carrying a 4,000-pound pallet to spin 360 degrees inside narrow warehouse aisles measuring less than 10 feet wide, keeping the entire vertical racking network accessible. Finally, for horizontal transport across sprawling manufacturing floors, facilities deploy automated warehouse tuggers. These compact electric units act as miniature locomotives, hauling linked trains of rolling component carts silently along magnetic floor tracks to keep assembly lines fed around the clock. From the smallest warehouse electric pallet jack to the massive Class 8 line haul giants, every single vehicle serves a specific purpose to keep the modern world moving forward. If this look at all the different trucks in logistics gave you a new respect for the supply chain working behind the scenes, hit subscribe. Turn on notifications and comment below which truck surprised you the most. Thanks for watching and see you in the next one.